At the turn of the 20th century, Galveston, Texas was a bustling metropolis, fueled by the promise of prosperity and boundless optimism. Yet on the fateful morning of September 8, 1900, residents of Galveston awoke unaware of the approaching storm that would forever change their lives. There was no forecast to warn them. A Category 4 hurricane swept in off the Gulf of Mexico. Caught unprepared, 6,000 people died that day. It was the deadliest weather disaster in American history. Today, after over 100 years of innovation and research, hurricanes are much better understood and forecasts are increasingly more accurate. Our ability to predict the track and intensity of hurricanes saves thousands of lives and yields an economic cost savings of nearly $200 million annually. Scientists at NOAA's Office of Oceanic and Atmospheric Research, known as OAR, are at the forefront of hurricane research. These scientists provide critical research and models that ensure forecasters have the best oceanographic and atmospheric information available to them. As each hurricane is formed, NOAA hurricane scientists and their partners immediately begin their work studying the storms in the lab and in the field, tirelessly pursuing an understanding of where the cyclones will go and how strong they will become. Within OAR, Tim Marshock and his colleagues use mathematics to improve our predictions of the behavior of hurricanes.
Not only can a hurricane model give us an idea of the track where a hurricane is going to go, but it also gives us an idea of how intense a hurricane is going to be. One of the more recent advances in hurricane modeling is the coupling of an ocean model to the atmospheric hurricane model. And that's critically important because the ocean is the source of fuel for the hurricane. Now, with the coupling to an ocean model, we can allow the ocean and the sea surface temperature to evolve throughout the course of the forecast. And that gives a better depiction of how the storm is going to evolve and how the intensity may react to the evolution of the sea surface temperature. One of the elements that's really key for a good hurricane model forecast is having good quality observations that come into the model. If we don't have a good picture of exactly how the atmosphere looks like right now, then we have no hope of being able to predict what it's going to be like tomorrow, the next day, or 5 days from now. So we need good quality observations as input to the model.
In addition to satellites, weather buoys, and land-based instruments, aircraft flown directly into the storms collect essential observations to unlock the secrets of hurricanes. Shirley Murillo is a part of an elite team of NOAA meteorologists and pilots who face the dangerous mission of flying into the very eye of hurricanes.
It's important for us to fly inside the hurricane because there is nothing like collecting data to improve our hurricane forecast models than to be inside the storm. These aircrafts are unique in the sense that they're essentially a flying laboratory. We have a tailed Doppler radar, we have several other radars on board, dropsondes and cloud physics instruments, and that's available to the hurricane forecasters, to the entire community, to the storm surge modeling community, to diagnose what the wind field is in real time.
NOAA researchers are investigating new ways of collecting atmospheric observations, including outfitting oil platforms with water vapor instrumentation and launching fleets of weather balloons to collect data in the path of hurricanes. Additionally, NOAA and other partners are now testing a new breed of hurricane hunters, unmanned aircraft that fly higher and sustain significantly longer missions than conventional aircraft. Although NOAA scientists are pleased with the advancements in hurricane tracking, they remain confounded by one threat: rapid intensification.
Charley and its approach to the southwest Florida coast in 2004 was an example of rapid intensification, which is an increase in strength of at least 30 miles per hour in 24 hours. Charley actually went from a Category 2 hurricane to a Category 4 hurricane in about 5 hours' time, right before landfall. When that happens, people find a storm that perhaps they haven't prepared for, and that can be very serious.
Charley was the first in a destructive string of hurricanes making landfall that spun out of the Atlantic Basin during the historic 2004 and 2005 seasons. Nearly 4,700 people died, and damage amounts exceeded $150 billion. As a result, a new urgency for better intensity forecasting swelled in Congress, and the Hurricane Forecast Improvement Project was launched.
So what we've been doing in NOAA is we've started what we call the Hurricane Forecast Improvement Project that came about after the 2004 and 2005 hurricane season as a way for NOAA to put a focus on the intensity forecast problem, which was the #1 issue that the National Hurricane Center put out there as their challenge.
Research has found that enhanced NOAA GOES satellite imagery will improve hurricane intensity forecasts, resulting in an economic cost savings value of $191 million per year.
In the new internet age where information is at your fingertips all the time, I can't stress how much we need to get information out to people. They're demanding it, they want it, they expect it.
NOAA is saving lives and property by creating a society that is prepared for and responds to weather-related events. Through innovative research, scientists will meet this challenge and provide ever-improving hurricane forecasts to those who depend on them most.